Today we are going to talk about a second method for solving quadratic equations, and that is using something called the square root property. So let's take a look at that property first, and then we'll apply it. The property says if b is a real number, and if a squared is equal to b, then a is equal to the positive or negative of the square root of b. Basically what this is saying is if you are trying to solve this equation right here for a, if you want to get rid of a square, the opposite of squaring is square rooting. That's basically what this property is saying. And squares and square roots cancel, which is why we have a over here, and the square root is with the b. This plus or minus is super important. Whenever we are solving an equation that has an x squared in it, there will always be two answers. And that's basically what that is saying, is there's a positive answer and a negative answer, and it's whatever the square root of b is. Now, we're not going to be using our calculators as much as you would like. Okay, I'm not interested in decimal answers. When we get to the square root part of it, we're going to be using our factor trees that we learned in the little previous pre-unit to simplify. So let's take a look at some examples together. This looks exactly like this property. Instead of a squared, it's x squared, and b is 24. So if I want x by itself, I am going to start by taking the square root of both sides. Well, the square root and the square are going to cancel. On the left side, all we have left is x. The right side, however, we need to work with the way we worked with them before. When you see a square root, we make a factor tree. Well, two numbers that multiply to give you 24 are 4 and 6. Those are not primes. Two numbers that give you 4 are 2 and 2. Those are primes. Circle them. Two numbers that give you 6 are 2 and 3. Those are also primes. Circle them. That's the end of our tree. Now, if you remember, when we did our tree, we always looked for pairs. Anytime you saw a pair, they got to come outside of the radical. So there's a pair of 2's. Here's my radical. A 2 is out front. This 2 and this 3 don't have pairs. So they stay underneath as 2 times 3. So our final answer that comes all the way down here with the x is, first thing, plus or minus always goes in front. Then we have 2 times the square root of, and 2 times 3 is 6. So it's using a lot of some old skills with just throwing in, using the square root on both sides and the plus or minus. But everything else is pretty similar to what we've already done. So let's look at b. Now b is similar to a. The problem is it has a 3 there, and we can't use square roots if there's a 3 there. So the first thing we're actually going to do is get rid of this 3 by dividing by 3 on both sides. That leaves me with x squared equals negative 36 divided by 3 is negative 12. Now this looks just like a. So we're going to square root both sides. Now again, the square and the square root cancel. So we have x all the way down here at the bottom. We need to make a tree. Now, I want to point out there's a negative here. We've seen negatives before. So this negative, the first line, the first part of our tree is a negative 1 and a positive 12. The negative 1 will be important in a minute. 12 is 4 and 3. 3 is a prime. 4 is 2 and 2. And those are primes. Now we are ready to move on, and I'm out of space, so I'm actually going to move this x over here. Now the first thing we need is a plus or a minus. We're looking for our pairs. Well, there is a pair of 2's, so cross those off. So I'm going to write down in front of the radical, a 2. The other thing we get to cross off is the -1. If we see a -1, when we cross him off, we put an I in the front, and the only thing that's left over is the 3. He has no partners, he goes underneath, and that is a done answer. So hopefully you're looking at these thinking, oh, these aren't nearly as tough as maybe the previous lesson. Let's do a couple more together, and then I'm going to have you try a couple. So let's look at these. Example A, again, we're not ready to square root because this time the 50's on the wrong side. So we're going to start by moving this 50 by doing the opposite, which is adding 50. That leaves me with x squared equals 50. That is ready to be square rooted. So I'm going to square root both sides. Squares and square roots cancel. Down here, I have x equals. I need to make a tree for 50. Well, 50 is 5 times 10. 5 is a prime number, circle it. 10 is 2 times 5. Those are both prime numbers, circle those. What am I looking for? I'm looking for pairs. Cross off my pair of 5s. Come down here. Outside of my radical, I put a 5. The only thing left over is the 2. The 2 goes down inside of here. What's the one thing I'm missing? That's right, the plus or minus. And that is a done answer. One more together, and then you're going to try some more on your own. This one, we have several things to do. First of all, this 14, he's got to go over here. The opposite of a positive is a -14. That leaves me with 2x squared equals 0 minus 14 is -14. Next, I want to get rid of this 2. I'm going to divide by 2. That leaves me with x squared equals -14 divided by 2 is -7. Now, I'm ready to square root. Square root both sides. Square and square root cancel. I have x down here by itself. Let's look at the -7. Notice I said it was negative. That means the first branches are a -1 and a +7. -1, he'll be important in a minute. 7, is 7 a prime number? It is. So that tree is done. Well, we're looking for pairs. Here's the problem. There's no pairs. So I'm going to write down my square root. The 7 doesn't have a partner. That means he stays inside. The -1 gets to come outside as the letter I. What's the only thing we're still missing? The plus or minus, and that is a done problem. So I would like you to pause the video. I would like you to try these two on your own. Okay, let's see how you did on these. You should have started by subtracting 72. That should have left you with x squared equals 0 minus 72 is -72. You should have at this point square rooted both sides. Cancel. And we're left with x equals -72. Hopefully when you started your tree, you started with -1 and +72. It'll be important in a little bit. 72 is 8 times 9. Those are not prime numbers. 8 is 2 times 4. 2 is a prime, 4 is not. 4 is 2 times 2. Those are primes. And 9 is 3 times 3, and those are primes. You should have now been looking for pairs. Well, there's a pair of 2's. So in front of my square root is a 2. There's a pair of 3's. Also in front is a times 3. This 2 stays in here, So we end up with 3 times 2 is 6, square root of 2. But what's missing? Hopefully you remembered the plus or the minus. Oh, Miss Simon forgot about the negative 1 right here. That negative 1 should have come outside as an I, so there should be an I with both of those. That is the final answer. Hopefully you got that one right. Let's see how you did on B. You should have started by subtracting 200. We are left with negative 5x squared equals 0. Take away 200 is negative 200. Divide by negative 5. You should have gotten x squared equals negative 200 divided by negative 5 is positive 40. Hopefully that part you did right. You should have been ready to square root both sides. Those cancel. We're left with x equals 40. Let's make a tree. 4 and 10, those are not primes. 4 is 2 and 2, those are primes. 10 is 2 and 5, and those are also primes. What am I looking for? I'm looking for pairs. There's a pair of 2's. In front of the radical is a single 2. 2 and 5 are not a pair. They both go inside with multiplication. And so our final answer should have been 2 square root of 10 with a plus or a minus in front. How did you do on those? Hopefully they weren't too bad. So we're going to add one more little piece to our problem. So let's move on and do a couple more together. So a little different, we have parentheses now. Okay, when you look at the parentheses, they're okay. This is the piece that we're trying to get rid of, the square. So I'm going to square root both sides, just like the previous problems. The 1 can't go anywhere. The 1 is inside the parentheses, so don't move him, at least not yet. The square and the square root cancel. At the same time, the parentheses will go away, and we're left with x plus 1 equals 12. We need to make a tree. 12 is 4 times 3. 3 is a prime. 4 is 2 times 2. Those are primes. Our pair of 2's gets crossed off. Outside of our radical, we put a 2. The 3 comes down. And the only other thing we need is the plus or minus. The difference is we're not ready to put a box around this because x is not by itself. We need to now get x by itself by subtracting 1. This is where we like to make our mistakes. This is a regular number. This 2 and this radical are together. So this is a regular number. This is a radical. So they cannot be combined. So the way we write our proper answer is you write the regular number first, then the plus or minus, then the radical number. And that is a done answer. Let's try another one, and then you're going to try a couple on your own. First thing we need to get rid of, not the 5, just the 2. Square root, both sides. Those cancel. Down here we have x minus 5 equals negative 16. I said negative, so that means automatically I start with negative 1 and positive 16. 16 is 4 and 4. Those are not primes. 4 is 2 and 2. Those are primes. That 4 is 2 and 2, and those are also primes. So let's see what we have. We're looking for pairs. So a pair of 2's, 1, 2 goes in front of my square root. another pair of 2's. Another 2 goes in front of my square root. A negative 1 goes away, and an I goes in front of my square root. And what is left over? Nothing. There's no square root on this answer. So down here, I'm going to put 2 times 2 is 4i, but I still need the plus or minus. That will never go away. Is this a done problem? No. We're going to do just like what we did over here on this problem. I'm going to add 5 to both sides. X equals, again, real number, imaginary number. They cannot be combined. We write the real part first, plus or minus, then the imaginary part. And that is a done problem. So we're going to have you turn the page, and I would like you to try these two on your own, and then we will go over them. So let's see how you did. You should have started by square rooting both sides. Cancel, cancel. Down here we have x minus 3 equals 90. Well, you could start with 9 and 10. 9 is 3 and 3. Those are prime numbers. 10 is 2 and 5. Those are also prime numbers. You should have then started looking for your pairs. There's a pair of 3's. So in front of my radical is a 3. The 2 and the 5 don't have partners. So 2 times 5 stays inside. So down here, I have 3 square root of 10, with, of course, a plus or minus. The only thing you should have done next was add 3 to both sides. And hopefully you remembered this guy and this mess are not like terms. So it's whole number plus or minus radical number. And there you go. Hopefully you got that one right. Let's take a look at part B. Hopefully you started by square rooting both sides. Those cancel. And down here we have x plus 2. The square root of negative 20. Negative 20 means we start off with negative 1, positive 20. He's done for the moment. 20 is 4 times 5. 5 is a prime number. 4 is 2 times 2. Those are both prime numbers. So we are looking for our pairs. Well, there's a pair of 2's. So outside my radical is a 2. The 5 has no pair. He stays inside. And the negative 1 crosses off and becomes an I. So down here, we're going to put plus or minus 2i square root of 5. And your last step should have been to subtract 2. We get x equals real number first plus or minus imaginary mess second. And that is a done problem. And hopefully you got both of those correct. We have one final pair of problems. We're going to try one. You're going to try one. These have one more extra step. So let's do the first one together. I need to get rid of the squared, just like every other problem. I'm going to square root both sides. The squares cancel. Down here, I'm left with 2x plus 8 equals negative 16. Well, our tree starts off with negative 1 and positive 16. 16 is 4 times 4, and the 4's are 2 times 2. And those are all primes. We need some pairs. Well, there's a pair of 2's. So in front of my radical is 1, 2. There's another pair of 2's. So in front of my radical is another 2. The negative 1 is an I. And is there anything left over? No. This one has no radical. The answer is 2 times 2, which is 4i. Don't forget about your plus or minus. Now, we are not done getting x by itself. Just like the previous pair of examples, you want to move the 8 by subtracting 8. However, we're not left with x. We still have 2x equals, negative 8 comes first, plus or minus imaginary part. Well, last little step, this is new. How do I get x by itself? I need to get rid of that 2 by dividing by 2. Well, which one do I divide by 2? The answer is both. I'm going to divide both numbers by 2. So my answer is x equals negative 8 divided by 2 is negative 4, plus or minus 4i divided by 2 is 2i. Done answer. Pause the video. Try this last example by yourself. Let's see how you did. Hopefully you square rooted to start with. Cancel, cancel. Down here you're left with 3x minus 15 equals negative 36. Hopefully you did negative 1 and positive 36. 36 is 6 times 6. 6 is 2 times 3 primes. And this 6 is 2 times 3, and those are primes. Hopefully you were looking for your pairs. Pair of 2's. Here's my radical. There's a 2 in front. Pair of 3's. Put a 3 in front. Negative 1. Put an I in front. Is there anything left in here? No, the radical is gone. So down here we're going to make it plus or minus 3 times 2i is 6i. Hopefully you got that part right. Next step you should have done was add 15 to both sides. We still have 3 with our x. We put the real part first, plus or minus the imaginary part second. And then hopefully, just like this example over here, hopefully you finished by dividing all 3 numbers by 3. Cancel. Final answer, x equals 15 divided by 3 is 5, plus or minus 6i divided by 3 is 2i, and we are done. So, I will see you in class next time.